In professional communication, we operate in an environment where a single unseen structural failure can collapse an entire proposal. You are traditionally taught to group sentences into paragraphs based on a shared topic. But a paragraph is not a collection of sentences. It is a tightly engineered argument. There is a persistent assumption that if your English grammar is flawless, your point is automatically effective. Syntax and vocabulary dictate how you organize your ideas. They do not test whether those ideas actually hold up to scrutiny. Logic does. A perfectly structured sentence can easily carry an idea that is factually weak, demonstrably wrong, or deeply misleading. Your objective now shifts. You are no longer merely gathering sentences that sound supportive. You have to prove that your support actually validates your claim. Mastery of the language requires moving past syntax to engineer the cognitive mechanics of your argument. Think of a basic logical argument as a physical, sequential chain. The first two nodes are straightforward: the claim, what you are stating, and the reason, why you believe it to be true. These statements require two structural supports: evidence, your raw data, and the link, the mechanism proving the claim. Take a weak statement. Exercise is good because it helps. The connection is vague, causing the structure to drift apart. Compare that to stating, exercise is beneficial because it improves cardiovascular function, which increases endurance. By introducing a precise mechanism, you create a connection that withstands direct scrutiny. If the link explaining exactly why the evidence works is missing, the entire argument will inevitably collapse in a vacuum. Once your argument is structurally intact, it needs propulsion. That drive comes from one of three distinct types of reasoning. The first is deduction. This is the process of proving a conclusion by applying a known general rule to a specific case. Deduction illustrates absolute certainty. If all humans need oxygen and I am human, the final block locks into place. I need oxygen. If premises are true, the result is guaranteed. The second type is induction. Here, you observe a pattern of data to suggest a conclusion. If sleep always improves performance, the trajectory points there. It's highly likely, but leaves room for error. The third is abduction. You start with a single observation and decide on the most plausible explanation. If a patient gets dizzy only when turning their head, you conclude vestibular involvement. You are seeking the best fit based on the evidence. Selecting the correct reasoning engine gives your argument its persuasive power and defines exactly how an opponent can attack it. Arguments in the real world rarely fail because of a misplaced comma. They fail under pressure due to mechanical breakdowns in thinking. These mechanical failures are known as logical fallacies. This represents an overgeneralization. It happens when you take a highly limited data point, like failing a test once, and stretch it into a universal claim, like I am terrible at this. To fix an overgeneralization, you have to limit the blast radius, add parameters, use qualifiers like often, sometimes, or in this specific case. Next is the false cause fallacy, assuming one event caused another because they happened in close proximity. For example, wearing lucky shoes and winning. Two events flash simultaneously, but without a proven mechanism, there is no true causation. Then there is the missing link. This is the act of jumping directly from a claim to a conclusion while entirely skipping the explanation of why it works. Identifying these three structural errors allow you to reinforce your logic before it is subjected to empirical pressure. Other fallacies do not shatter the structure. They act as navigational errors, manipulating how the audience perceives the logic chain. An appeal to emotion tactically replaces rational logic with feeling. Saying, "This is wrong because it feels unfair," is invalid. The feeling must be systematically isolated from the reasoning. This displays a false dichotomy. It presents only two extreme options. Either you succeed or fail, while intentionally graying out a wide spectrum of functional middle pathways. Circular reasoning is the ultimate dead end. The claim simply repeats itself, masquerading as proof. Stating a method is effective because it works well feeds the output directly back into the input. It generates zero forward momentum. Finally, a weak analogy attempts to dock two concepts that lack meaningful similarity, like claiming language learning should be fast because it is just like driving a car. Surviving a logic stress test requires ensuring your argument is driven forward by undeniable mechanisms, rather than manipulation, false choices, or repetition. To actively apply this theoretical framework, you must be able to run a real-time diagnostic scan on incoming arguments. Watch this interface lock on to a single, flawed sentence from the noise. Everyone uses this method, so it must be correct. Step 1 of the diagnostic: identify the reasoning engine. The statement observes a pattern of behavior to suggest a conclusion. That makes it induction. Step 2, identify the fallacy. Taking the observation that many people use a method and stretching it to claim the method is inherently flawless is an overgeneralization. This diagnostic framework enables you to evaluate the logical validity of an argument as quickly as you process its syntax. High-stakes professional communication demands that you actively control these underlying mechanics while defending your ideas under intense, real-time pressure. True fluency is the result of matching precise grammar with the cognitive resilience to dissect and adapt to logical disagreement.